this is going to be Efail and other failures with encryption and email, as you can see on the screen behind me. If you're looking for the defense informs offense improves defense talk, that's in the room right next door. But I think you all want to hear Hanno. So as we now also have a clicker, thanks to McLemmon. Turn it. Yeah, okay. So without further ado, please give a very warm welcome to Hanno Beck.
Yeah. Hello. Yeah, I'm going to talk about email encryption. So I would like to know who here is using email encryption. Yeah, a few. Isn't it really painful? Like you still continue to do that? Okay, so let's assume we have Johnny. He's like an average user, but he wants to encrypt his emails because he has heard, yeah, there's all this surveillance and he wants to encrypt emails. And he wants to use PGP because he heard that this is very secure. But of course, PGP has this reputation of being difficult to use. Actually, it's not really called PGP. We all know that because PGP, that was kind of back in the 90s, and today we call it OpenPGP. So someone explains to Johnny, yeah, it's not PGP, it's OpenPGP. So Johnny asks, how do I install OpenPGP? Well, that's not how this works, of course, because OpenPGP is just the name of the protocol. The actual software you usually use is GNU-PG. Okay, so Johnny asks, how do I encrypt emails with GNU-PG? So, well, of course, you cannot just use GNU-PG to encrypt emails because it's just the underlying encryption software. You need an email application, something like Thunderbird, which is what many people use, and you need a plugin like Enigmail. Of course, at this point, most users will already have given up. But not Johnny. Johnny, let's just assume Johnny actually hasn't given up and still wants to encrypt his emails, and he tries to install Enigmail. So yeah, he already has Thunderbird, and then he finds this functionality to install add-ons, and he finds Enigmail. So this dialog here says, install add-ons only from authors whom you trust. We should remember that. We will come back to that. Okay, then he clicks on install, and then this says, Enigmail unable to locate GNU-PG executable in path, blah, 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 something. But here he says, okay, the easiest way to do this is using the setup wizard button below. So he does that, assuming he didn't just click OK, because that's what people usually do. But now Johnny is a bit scared because it's all very confusing. Then comes the next dialog. In order to use Enigmail, P equals P, GNU-PG is required. As we could not find it, we suggest to download and install it for you. I mean, that's kind of the same thing we just had. So Johnny is still very confused. Like, why do you ask me again? And also, what's this P equals P thing? Is it another thing I need? And yeah. Okay, then he clicks on OK, and then this comes up. So, do you want to allow this app from unknown publisher to make changes to your device? We remember earlier we heard, like, don't trust things from unknown publishers, but now we should install this thing from publisher unknown. But okay. Johnny is really scared now, but he still clicks yes, because he wants to encrypt his emails. Then this comes up. So choose which features of GPG for Win you want to install. I mean, what's GPG for Win? Is that yet another thing? I don't know. And here's like, he could install Cleopatra, GPA, GPGOL, whatever. Yeah, so yeah, Johnny is very confused now. But he goes on, he clicks OK. Then there's this, oh, encrypt emails in Outlook with GPGOL. Like, Outlook? Like, what? Didn't we use Thunderbird? Like, Johnny thinks, I'm not using Outlook. Have I installed the wrong plugin? What's going on here? You also may end up with this, like, Windows Defender Firewall has blocked some feature of this app. Name dir mngr.exe. That sounds scary. Like, now Johnny is in panic. He thinks he has installed a virus, right? I mean, this dir mngr.exe, that really sounds like a virus. And like, I'm not making this up. Like, I googled for dear MNGR virus. This came up like a forum from Malwarebytes, which is an antivirus application where someone says, yeah, request assistance, possible malware, dear MNGR GNU-PG. So yeah, so usability is not PGP's strength, which is not really called PGP, and yeah. But is it secure? Like, we can encrypt emails and we can sign emails, and then we hope that this is secure, right? So yeah, we can sign emails. This is a signed email. What do you think about that? Does it look good? It's green, right? It looks good. I mean, that was a fake. What I did here is like this green thing that says good signature from Alice. That's just a picture, like a PNG image that I put into the mail. So yeah, so this green thing that says this is a good signature, we can just emulate this with an HTML mail. So this is how the real mail looks. Do you notice the difference? Like, there's this red symbol here with the letter that you cannot fake as an attacker. So what we have here is a security indicator in attacker-controlled space, and that's not very good. Like, if our attacker can tell us that something is secure, that's not good. This works even better in some other mail applications. This is Kmail. Anyone using Kmail? No. Okay, so this is like exactly identical. Like, you have a signed email, which is like a real signature, and you have one where you just rebuild this green border around the mail with HTML, and there's no difference. So how could we fix this? This is what Enigmail came up with. So they kind of just moved the green bar from the email to the top. Now, this is the obvious thing to do, like you move the security indicator out of the attacker-controlled space. But I still think this is not a very good solution, but it's a complicated problem, because when we talk about security indicators, we need to talk about, yeah, do users actually understand them? The answer is usually no. They have no idea what you're telling them. And like, if we look in other areas, particularly browsers in the web, we're going in a completely different direction. We're saying, like, we don't want to have these green locks anymore. We want to have the secure thing to be the default and only give a security indicator if something is wrong. This is obviously not very feasible for email, but that's kind of the direction where we're going in other areas. Okay. Okay, that's from outside. But now we can also encrypt things with PGP. So here we have Johnny, and he writes an email to Alice, like, hello Alice, this is a very secret message. Then Alice gets that email, it says decrypted message, and then Alice answers to that email. And Alice is using tofu quoting, like she's just quoting the whole mail and then writing something for herself. Does anyone notice anything here? Louder, please. No, that's encrypted, but the mail address of Johnny looks a bit strange. Like, the O has been replaced with a 0. So now the email goes to someone else. So the attacker, Mallory, she just changed the from address in the mail on the server. Because like, the idea of PGP is we want to defend against someone malicious who potentially can access the server, changes the from address, which is not part of the encrypted email. It's just the mail header, which is not protected in any way. And the interesting thing here is that at this point, you cannot see that, because at this point, the mail address is still correct. So what's going on here? So yeah, so there's a thing, a standard called memory hole, which the idea is that we start protecting email headers in GPG. Like if you get emails from Thunderbird users and your mail client doesn't support this, you may have noticed that they no longer have subjects, but they just say encrypted subject or something. So the idea here is that we have some mail headers that we have both in the mail header itself and again within the encrypted email part. And what Enigmail here does is that for displaying the message, it uses the from header within the mail. But if you click on reply, it uses the mail header from the unprotected mail header from above. So yeah. So you could wonder if we protect the mail headers, if it prevents the attack, but right now it doesn't, because like you can have inconsistent headers, and Enigmail and Thunderbird will use the unprotected header if you reply to a message. So yeah. So what I think it should do, but I'm currently in discussion with the Enigmail author, is that it should treat it as an error if you have a inconsistency, if you have a different from in the mail itself and in the encrypted part. Yeah, we'll see how that will play out. Okay, let's steal some passwords. I have a little video for this. So again, we have Johnny, and he wants to write an email to Carol. So he starts typing in the mail address, and then yeah, writes the subject, and then something strange happens. There's a pop-up that says, something is requesting your username and password. The site says, please enter your username and password. And Johnny is naive, and he types in his email username and password, because if my mail application asks me for username and password, like that's, yeah, I type it in. Comes again. So what's going on here? So there's a thing which is called web key service, which is currently a proposal for a new way to distribute keys in PGP. And how this works is very simple. It's basically using HTTPS to fetch keys. So if you write to, in this case, hanno@example.org, then you fetch this key from this .wellknown.openpgp key something, and this is a hash of the local part in some encoding. And whenever you have an email address in the to field in Enigmail, it will automatically try to fetch it with this web key service protocol. Now in this case, on this server, I enabled HTTP authentication. So Enigmail tries to fetch the key from my mail server, and then I say, hey, you need to authenticate that. And then Thunderbird says, okay, let's pop up this authentication dialog. Like, which, it kind of doesn't make any sense that Thunderbird even has this functionality, but Thunderbird is basically using the Mozilla browser engine, and that has everything that a web browser supports. So it also has HTTP authentication. So I can, from someone else, pop up a login dialog within the email client, and I can read whatever this person will type in there. This is not fixed in the current version of Enigmail. I reported this, and then I learned, like the developers told me, that we already know about that. It has been reported 2 months ago. It's not fixed yet, whatever. Okay, but now we get to Efail. Now, for this, we first have to understand that Efail is not one attack, but it was multiple attacks, was published by a research team in spring, affects both OpenPGP and SMIME. And like the simplest attack was basically exploiting some property of email MIME parts. So what you have to understand here is that with MIME, an email can have multiple parts. So this is usually used for attachments, but you can also have multiple parts, like you have multiple text parts or multiple HTML parts. And this attack, like this is so simple, it's hard to believe that this works, but let's assume you have an encrypted email and you want to know the content. Then you send this encrypted email to that person, but you put something in front of it, which in this case is some HTML that, for example, may open an image tag. And as a source, you enter some server that you control. And then you put in the encrypted mail as another mail part. And then you put in another part that closes this HTML image tag. And what this will result in is that the mail program will try to fetch an image from that server and add the whole encrypted part as a parameter. Yeah, so this super simple attack that worked on multiple email clients, in some it even worked by default, like for example in Apple Mail. In Thunderbird, it only worked if you allow loading external content. That's disabled by default, but yeah. But of course, when Efail was published, this was already fixed. At least that's what they told us. Like here, for example, a developer who is involved in Enigma, he said, yeah, if you're using recent GNU-PG and Enigma 2.0 or later, you should be fine. If you're not, and so on. So he's basically claiming, yeah, we already fixed this. It's no big deal. But it was not really fixed. Like this one didn't work anymore. That's true. But then you change it a bit, and like I tried this a few days after Efail was published, and after they claimed, yeah, this is all no big deal and it's all already fixed. So here we are building an HTML form. Again, with target is a server that the attacker controls. And then we add a text area element, which if you know HTML, like in a form, if you have a multi-line input, that's basically a text area. And then as the content, we have the encrypted email. And then we close the text area. Then we add a button, and this button we just put over the whole email with CSS. Like, so the whole email is a button. And if you click anywhere in the email, then it will send the decrypted content to the attacker. This still worked after Efail was public, and after various people claimed this is all already fixed. And yeah. Okay, this was very simple, but there was another attack because the main attack in Efail was a crypto attack. And there, and if you use crypto, if you use symmetric algorithms like AES, the advanced encryption standard, which is kind of the standard encryption mode everyone uses these days, this is a block cipher, which means it can encrypt a block of data, which is 16 bytes, I think. And so if you want to encrypt something that is longer than 16 bytes, you need some kind of encryption mode where you use AES multiple times to encrypt things. And there are some encryption modes that I would say they are legacy encryption modes that were developed somewhere in the 80s and 90s that guarantee that your data is secret, like you cannot just decrypt it, but they do not prevent modification of that data. And there are more modern encryption modes, which are called authenticated encryption. And they guarantee not just that the data is secret, but also that it's protected from modifications. This concept was introduced in 2000, so 18 years ago. And GCM, which is a standard mode that is recommended by NIST and several standardization authorities, it was standardized in 2007. So that was 11 years ago. So that's pretty new, like bleeding edge technology. Maybe it's not so new, but I'm just saying this and emphasizing like that this is more than 10 years old, because occasionally then people say, yeah, this is this new stuff. You cannot expect that we use this new stuff already. I mean, yeah. Yeah, it's not so new. And that's what you should use if you build crypto. But OpenPGP, I mean, it's been developed in the 90s. It uses something called CFB, cipher feedback mode. And this is not authenticated. And this is how it looks. So don't be too scared by this complicated image. But the important thing here is that you can see if we decrypt something, every time we're XORing the ciphertext, and this directly relates to the resulting plaintext. Now what that means is, if we can modify the ciphertext, and if we know something about the plaintext, we can do a controlled modification. Like, let's assume we know that this plaintext here is hello. Then we can modify this ciphertext block by XORing hello on it and then XORing something else on it, and then we can control what the result here will be. This will of course result in that this ciphertext we modified will be decrypted and the output will be garbage. But what we can do is, like, we can inject some modifications into this encryption, and then we can control one block, and then we will have one block of garbage. And so this property is called malleability. So whenever you have an encryption and you can kind of do some controlled modification that will lead to a controlled output modification, that we call malleability in crypto. So yeah, what that means is, if the attacker can predict a block in the plaintext, then he can inject controlled content blocks with some garbage in between. So the idea of the Efail attack with this was, we modify a message in a way that it will contain HTML, and that will send message content to the attacker. And to illustrate this a bit, here I have how this would look like. So we could, and these things on the left are all 16 bytes because that's the block size. And as we said, we can control one block and then have some garbage. So we add an image tag, and then we add an attribute A, which doesn't make any sense, but we just need this to kind of contain the garbage. So then we have quotes, and then we have some garbage, and then we have quotes again, and then we have a source tag, and then HTTPS, and then again some garbage, and then we add an @ because that means the garbage will be turned into a username, which is kind of irrelevant. It's just, again, to contain the garbage. And then we have our attacker server, which in this case may be efail.de. And then we append a variable to that URL, and then we add the encrypted message. So with this, we can modify the ciphertext in a way that it will contain HTML that will send the decrypted content to the attacker. There's one thing, like if you use this on PGP, is that it uses compression, which makes things not so easy because it's pretty hard to predict to have known plaintext blocks. But the authors of Efail managed to make this work in a third of the cases. But they also emphasize that it's probably possible to improve this attack a lot. It was just they tried to show that it's possible, but there may be more. So this would be prevented if we had authenticated encryption, right? Because we said authenticated encryption prevents changing the ciphertext in controlled ways. But we didn't have authenticated encryption back in the 90s when PGP was introduced. But PGP has something which is called a modification detection code, or MDC. And like Werner Koch, the developer of GNU-PG, claimed in an email recently that their PGP is using authenticated encryption because we have this MDC. So we can ask, is that authenticated encryption? And there's some good news here. Like this MDC thing, it's an ad hoc construction. It's not really analyzed very well, but it seems nobody has found any real weakness in it. So, okay. Let's hope that this is secure. But the bad news, this MDC is optional. So PGP has different message packet formats, one of them with MDC and one of them without, and you can transform them. So if you have a message with this MDC, you can just remove it, then change something in the header, and it will still be a valid PGP message. This was for backwards compatibility. Of course, backwards compatibility is always this issue. There's more. And then we have to kind of ask, what does authenticated encryption actually exactly mean? And if you look up the paper where this was introduced, they give a pretty good definition, where they say, yeah, in such a scheme, the encryption process applied by the sender takes the key and a plaintext to return a ciphertext, while the decryption process applied by the receiver takes the same key and a ciphertext to return, and that's the important part, either a plaintext or a special symbol indicating that it considers the ciphertext invalid. So what this says is, if we have authenticated encryption, the decryption is either the plaintext or it's an error. So then we know someone has manipulated our encryption. Now, this is what GPG is doing, at least if you use the so-called streaming API, which basically means you use standard in, standard out for decryption. It either gives you the correct plaintext or it gives you the modified plaintext, and then at the end it will tell you, yeah, but this was wrong. So you could argue authenticated encryption is also an API issue, and correct API should never output unauthenticated plaintext. And what happened here is that multiple mail clients just, if they got a plaintext and an error after that, they display the plaintext, and then they say, okay, but this was wrong. Like they show an error, but still display it. And then the attack still works because our attack just relies on that the client is rendering this HTML. If we talk about GNU-PG and the API, it doesn't really have an API. It's just a command line tool. This is intentional. Its author thinks that's how it should be. There's no libgpg. There's a library which wraps this all, but this is also just calling the command line tool, which is quite unusual, and maybe as we can see here, is also quite fragile. Okay, so how could we fix Efail in OpenPGP? So the first thing is we should fix stupid bugs in email clients where you can have multiple parts and they will be rendered together in one HTML. That just doesn't make a lot of sense. And what's now happening is, at least in Enigmail, is that it will not allow that you have multiple HTML parts for encrypted emails, where some of them are encrypted and others are not. Then you need to deprecate these unauthenticated modes and always require an MDC. This also has happened in Enigmail. Then they found out, okay, there are several of these enterprise email encryption gateways that still use the 1990s unauthenticated format, and then it breaks. But okay, yeah, backwards compatibility always an issue. Then you should never use the plaintext or display the plaintext if you have not checked the authenticity of the message, like the so-called MDC. And ideally in the future, we should switch to a real authenticated encryption mode. There's currently a draft for a new OpenPGP version where they plan to do that. Unfortunately, right now the draft is written in a way that you cannot really implement it in a secure way that meets this authenticated encryption definition. Because they kind of allow message parts that are up to several terabytes, I think, and so that would mean you would have to buffer terabytes of data and then check the authentication and only then output the plaintext, which is just not practical. But that's kind of the cryptographic details. Yeah. If you want to know more about that, talk to me later. We also need to talk a bit about SMIME. SMIME is this other email encryption standard. So we have two email encryption standards, OpenPGP and SMIME. I tend to say there are historic reasons for that, but no real reasons. I mean, occasionally people say yeah, S-MIME is for businesses and the other thing is for private people. I don't think this makes a lot of sense because I think all of them want the same thing. They want their emails to be private and secure, and but that's how some people see it. And Efail for S-MIME is much worse. Why? For one, S-MIME uses CBC mode, which is also an unauthenticated mode, and it has no authentication at all. Like, not even optionally, it's just you can modify the ciphertext in controlled ways, and there's nothing you can do about it with the current standard. It doesn't have compression, so the attack is much easier. You also have predictable parts because these encrypted parts usually start with the MIME header, which is usually always the same. So the attack is much easier, and it cannot really be fixed because there's no way to add authentication on that with the current standard. So S-MIME is kind of cryptographically broken. Then if I say this, then occasionally people come to me and say, no, that's just a problem with email clients and this HTML mails, and I disable HTML mails anyway and only use text. Okay, admitted, if you use S-MIME only for text mails, then it's still secure. You also cannot use attachments because attachments kind of have the same issue that you add active content. But that's not really practically relevant in my opinion. But yeah. So any active content in S-MIME, be it HTML mails or any form of attachments, is not secure. So if you would want to fix S-MIME, you would kind of have to define a completely new encryption mode, which would mean basically a new protocol. And you cannot have backwards compatibility because if you still support the old mode, then you still have the security issues. It even means people may be able to decrypt messages from the past that they have recorded at some point. So you could say this is good news because having one email encryption standard broken, then we only have one left, and then we have more compatibility. The problem is S-MIME may be insecure, but that doesn't mean people stop selling it. Because, I mean, one of the things is S-MIME, you can sell certificates, and yeah, it's a business model. And I mean, they just continue selling certificates for an insecure email system. Here's a free secure email certificate from Komodo, from DigiCert. We recommend email certificates S-MIME. That's also not a real sentence, but global science. So you can still buy these things. They don't seem to care that it's broken. I mean, if it works, you can understand this. Yeah. Okay. If we look back at how this Efail attack works, what does it mean in general for cryptography? Because I think there's a very fundamental truth behind this attack, and that is that if we combine unauthenticated encryption with any form of active contact, then it can compromise the secrecy of the content. Which is a bit counterintuitive because we said like these traditional modes, they only provide secrecy but no authenticity. But now we learn, okay, if we can break the authenticity, this may also break the secrecy. But yeah. And this is not just affecting email encryption. If you think about, for example, some people use encrypted zip files with passwords, also unauthenticated, or encrypted Word documents with passwords, PDFs. All of them are affected, basically. You could adapt this attack to all of these things. But I mean, of course, no new software would use unauthenticated encryption, right? I mean, that's all legacy stuff from the 90s. Nobody would do that anymore, except like, have you heard of this app, Vivi? Like if you're from Germany, that's an app from German health insurance companies. And it was, I think, a few months ago, they made a big buzz out of it. Now we have this very secure app for our customers where they can manage their health data. And they have had a certification from TÜV Rheinland, that said, yeah, this is state-of-the-art cryptography. They used unauthenticated CBC mode because, yeah, I mean, TÜV told them that this is state-of-the-art cryptography, so they use unauthenticated encryption. I mean, it's not that Efail was the first attack exploiting unauthenticated encryption. We had a bunch of attacks against TLS, which were exploiting the fact that TLS was using authentication, but was using it in a kind of weird way that turned out to be not very secure, which created so-called padding oracle attacks, and also Poodle, which was against the old SSL3 protocol, and later a timing version of these padding oracles called Lucky 13. Also, there was an attack against XML encryption, which was based on error messages in decoding stuff, and there was some vulnerability in iMessage, and all of them would have been prevented with authenticated encryption. So you kind of would think that by now you could know that it's state of the art, you should use authenticated encryption. And if I say this, then sometimes people come up, but what's with signatures? Because the signature also protects the message from modification, right? This sounds plausible, but it's not true. And here's the reason. Let's assume we have an encrypted message, which is encrypted for Alice, and it's signed by Bob. So Alice can check the signature and then say, yeah, everything's all right, and then display the message. Now let's assume Mallory wants to attack this, and she changes this encrypted message for Alice with Efail, as we learned earlier, into an Efail attack payload, I'll call it. And then we have this Efail attack payload and the signature, so the signature becomes invalid. So if the mail client checks the signature and then doesn't display the message, which is not what's happening in the real world, but let's assume a hypothetical email client would do that, then it could prevent displaying that message. But of course, Mallory isn't stupid. She knows that the signature is now invalid, so she adds a new signature, which is from her. But that totally doesn't matter, because the goal is not to show Alice a message from Bob. The goal is to show Alice a message that will exfiltrate the plaintext. So yeah. This also works. You can have a message without a signature. Yeah. So signatures don't replace authenticated encryption. And the kind of underlying reason is that there's no cryptographic binding between the signature and the actual encryption. So you can just replace the signature with another one from another person. Now you might ask, is there any hope for encrypted email? End-to-end encrypted email, it's big mess, many problems. There's one thing I wanted to briefly mention here, and that is, like, we not only have end-to-end encryption, but we also have transport encryption, and there's a new standard which is called MTA-STS, which at least gives us somewhat reasonable transport encryption between servers. So, I mean, if we talk to our own mail server, we usually use TLS already, but between the mail servers, there's the start TLS thing, but the problem with that is it's optional. And this MTA-STS gives us some way to make this non-optional. And I quite like it. It's relatively simple. So if you want to send an email to example.com as a mail server, you request a text record from this subdomain underscore MTA-STS. And then if you get something back which says this specific string version, STS version 1, then you know there's a MTA-STS policy, and then you fetch via HTTPS. And this policy, okay, it also has just the version of the protocol, and then it says enforce, which means if the connection fails with TLS, then you should not send this email. Then you have the MX, and then that basically tells you you should connect to that mail server, and you should verify that it has a valid certificate for that domain name. And it has a max age, so it says also store this policy for that many seconds, which this is the seconds in 1 week. but you can make it longer, of course, if you want to make it more secure. I made the experience that if many people who are used to how things work in DNS, they are very confused by this and they don't like it because they say, hey, but why do I have to have an HTTPS server? Maybe because HTTPS works and many other things don't. And why do I now need a certificate for every one of my hosts? Can't I just have a certificate for the MX? No, it doesn't work because DNS is insecure. And then people say this thing with DNSSEC, and then I think this is good because the things that DNS people did in the past didn't work in practice. I'm not gonna expand on DNSSEC today, but it's just nobody's using it, right? So it's not end-to-end encryption, but it's progress. So I wanted to mention it because it's at least something. It's better than what we had before. Yeah. Okay. Yeah. I'm through. End-to-end encryption. Yeah. Sorry, I was faster than expected. End-to-end encrypted email is a big mess. Has problems on all layers. Yeah. Thanks for listening, and I think we have some time for questions.
As you were quite fast, we do have time for a few questions. So if you could raise your hand, I will bring the mic to you. Or are you just sobbing in your... So Peppy, the quick solution would be the MX0 entry in DNS. Just be done with email. Otherwise, I think you're around, right? You're here, right, for the next 2 days.
Yeah, I'm here.
So
if you now hate me for saying SMIME is broken, or...
Oh, one question. Awesome.
Okay, I'll do one. Thanks for the talk. Do you have an opinion on PGP alternatives such as what Proton Mail is developing or Tutanota in Germany? Is that any better, or do you think it's just something different of the same stuff?
No, I don't think that. Like, there are a lot of companies that are claiming they are making email encryption more secure, and you mentioned two of them. These things look often really strange, and it's not really clear what their goal is, and yeah, I don't think that goes in the right direction.
Further question.
Also, there was you mentioned Tutanota. There was someone had reported to Tutanota that they were also using unauthenticated CBC mode, and the answer was basically they didn't understand what he was trying to tell them. I can look up the email for that. It's public. I think it was on full disclosure. Yeah.
Well, if there are no further questions, I would say another very warm round of applause for Hanno Beck. Thank you very much.